Stealth technology, also termed low observable technology, is a subdiscipline of military tactics and passive and active electronic countermeasures, which covers a range of methods used to make personnel, aircraft, ships, submarines, missiles, satellites, and ground vehicles less visible to radar, infrared, sonar, and other detection methods. It corresponds to military camouflage for these parts of the electromagnetic spectrum. The earliest application of camouflage in warfare is impossible to ascertain. Methods for visual concealment in war were documented by Sun Tzu in his book The Art of War in the 5th century BC in England. Irregular units of gamekeepers in the 17th century were the first to adopt drab colors as a form of camouflage. During World War I, the Germans experimented with the use of seलन, a transparent covering material, in an attempt to reduce the visibility of military aircraft. In 1916, the British modified a small SS-class airship for the purpose of nighttime reconnaissance over German lines on the Western Front. Fitted with a silenced engine and a black gas bag, the craft was both invisible and inaudible from the ground, but several nighttime flights over German-held territory produced little useful intelligence, and the idea was dropped. Diffuse lighting camouflage, a shipborne form of counter-illumination camouflage, was trialed by the Royal Canadian Navy from 1941 to 1943. The concept was followed up for aircraft by the Americans and the British. In 1945, a Grumman Avenger with the Hudi lights reached 700 meters from a ship before being sighted. This ability was rendered obsolete by radar. Chaff was invented in Britain and Germany early in World War II as a means to hide aircraft from radar. In effect, chaff acted upon radio waves much as a smoke screen acted upon visible light. The U-boat U-480 may have been the first stealth submarine. It featured an anchoactile rubber coating, one layer of which contained circular air pockets to defeat ASDIC sonar. Radar-absorbent paints and materials of rubber and semiconductor composites were used by the Kriegsmarine on submarines in World War II. Tests showed they were effective in reducing radar signatures at both short and long wavelengths. In 1956, the CIA began attempts to reduce the radar cross-section of the U-2 spy plane. 3 systems were developed: trapeze, a series of wires and ferrite beads around the platform of the aircraft, a covering material with PCB circuitry embedded in it, and radar-absorbent paint. In 1958, the U.S. Central Intelligence Agency requested funding for a reconnaissance aircraft to replace the existing U-2 spy planes, and Lockheed secured contractual rights to produce it. Kelly Johnson and his team at Lockheed's Skunk Works were assigned to produce the A-12, which operated at high altitude of 70,000 to 80,000 feet and speed of Mach 3.2 to avoid radar detection. In 1960, the USAF reduced the radar cross-section of Orion Q-2C Firebee Drivone. This was achieved through specially designed screens over the air intake, and radiation-absorbent material on the fuselage, and radar-absorbent. The United States Army issued a specification in 1968 which called for an observation aircraft that would be acoustically undetectable from the ground when flying at an altitude of 500 feet at night. This resulted in the Lockheed Y-03, a Quiet Star, which operated in South Vietnam from late June 1970 to September 1971. During the 1970s, the U.S. Department of Defense launched Project Lockheed Have Blue with the aim of developing a stealth fighter. The Northrop Grumman Tacit Blue also played a part in the development of composite material and curvilinear surfaces, low observables, fly-by-wire, and other stealth technology innovations. The success of Have Blue led the Air Force to create the Senior Trend program, which developed the F-117. Dielectric composite materials are more transparent to radar, whereas electrically conductive materials such as metals and carbon fibers reflect electromagnetic energy incident on the material's surface. Composites may also contain ferrites to optimize the dielectric and magnetic properties of a material for its application. Radiation-absorbent material, often as paints, are used especially on the edges of metal surfaces. While the material and thickness of RAM coatings can vary, the way they work is the same. Absorb radiated energy from a ground or air-based radar station into the coating and convert it to heat rather than reflect it back. Acoustic stealth plays a primary role for submarines and ground vehicles. Submarines use extensive rubber mountings to isolate, damp, and avoid mechanical noises that can reveal locations to underwater passive sonar arrays. Early stealth observation aircraft used slow-turning propellers to avoid being heard by enemy troops below. Stealth aircraft that stay subsonic can avoid being tracked by sonic boom. The simplest technology is visual camouflage, the use of paint or other materials to color and break up the lines of a vehicle or person. An exhaust plume contributes a significant infrared signature. One means to reduce IR signature is to have a non-circular tailpipe to minimize the exhaust cross-sectional area. and maximize the mixing of hot exhaust with cool ambient air. Another way to reduce the exhaust temperature is to circulate coolant fluids such as fuel inside the exhaust pipe, where the fuel tanks serve as heat sinks cooled by the flow of air along the wings. In addition to reducing infrared and acoustic emissions, a stealth vehicle must avoid radiating any other detectable energy, such as from onboard radars, communications systems, or RF leakage from electronics enclosures. The F-117 uses passive infrared and low-light level television sensor systems to aim its weapons, and the F-22 Raptor has an advanced LPI radar which can illuminate enemy aircraft without triggering a radar warning receiver response. Stealthy strike aircraft such as the Lockheed F-117 Nighthawk are usually used against heavily defended enemy sites such as command and control centers or surface-to-air missile batteries. Enemy radar will cover the airspace around these sites with overlapping coverage, making undetected entry by conventional aircraft nearly impossible. Stealthy aircraft can also be detected, but only at short ranges around the radars. For a stealthy aircraft, there are substantial gaps in the radar coverage. Thus, a stealthy aircraft flying an appropriate route can remain undetected by radar. Airborne or mobile radar systems such as AWACS can complicate tactical strategy for stealth operation. That's all for today. See you in another video.